Good morning, student. In this lecture, we are going to study one of the very important concepts, that is the three laws of thermodynamics. We all know that what is thermodynamics. Thermodynamics is the branch of chemistry which deals with the interconversion of heat energy into a various form of energies. See, whenever we study the thermodynamics, under thermodynamics we study some very important concepts, and those concepts are system, surrounding, and after system and surrounding, we talked about the various types of processes, and in various types of processes or with various type of processes there are three very important laws which are mentioned in thermodynamics, and these laws are known as laws of thermodynamics. So let's talk about the first law of thermodynamics. According to first law of thermodynamics, it says that energy is neither be created nor destroyed. The total energy of universe is always constant. So in other words, we can say that energy of the universe is always constant. Only what happens, the energy changes from one form to the other form. So here in this particular picture we see some diagrams, and with the help of this diagram we can understand the spontaneous process. In the next picture, here is the example of rusting. This is also the example. So generally when the rusting takes place, rusting of iron is an example of spontaneous process. Here are some other examples which talk about the spontaneous process. Okay, this particular example talks about the reversible process. So the process which can go in forward direction, or the process which can go in the backward direction, that is nothing but the example of reversible process. This another example is the example of irreversible process, and irreversible process is opposite of reversible process. Now before going to the second law of thermodynamics, another very important concept which we should discuss, and the important concept is entropy. So what is entropy? Like total energy, E, and enthalpy, the letter E, like total energy E and enthalpy H, entropy is also the example of state function. So delta S is equal to S final minus S initial. Simply entropy is denoted by the letter S. Another important formula of entropy is given here, which says that delta S is equal to Q reversible upon T, or QREV upon T. So what is QREV? It is the heat that is transferred when the process is carried out reversibly at the constant temperature, and T is nothing but the temperature in Kelvin. Here is the second law, and the second law of thermodynamics states that the entropy of the universe does not change for reversible reaction and increases for spontaneous reaction. It means if the particular reaction is reversible, its entropy will remain as it is. Its entropy will remain as it is, and for spontaneous process the entropy will increase. So here are some general points regarding the entropy. So whenever we will talk about the entropy of universe, the entropy of universe will be the sum of entropy of system plus sum of entropy of surrounding, and this entropy of universe will always be greater than 0. But if there is a reversible reaction, for a reversible reaction, entropy of universe, which is equal to the entropy of system plus entropy of surrounding, and this entropy of inner universe will be equal to 0, and this is for reversible reaction, or we can say this is for ideal reaction. But whenever we will talk about irreversible reaction, these irreversible reactions are real or spontaneous reactions. So whenever we will talk about the irreversible reaction, so for irreversible reaction, the entropy of universe will be equal to the sum of entropy of system plus sum of entropy of surrounding, and this entropy will be always greater than 0. Okay. So this is what is about the second law of thermodynamics. Now next, before going to the third law of thermodynamics, some important examples regarding the entropy are given here with the help of diagrams. Okay, now let's see the another law of thermodynamics, which is known as the third law of thermodynamics. Let's find out the third law of thermodynamics, where it is. Third law of thermodynamics. Here is the third law of thermodynamics, and what it says that the entropy of a pure crystalline substance at absolute 0 temperature, which is given by the formula, is S is equal to K ln W, which is also equal to K ln 1, which comes 0. So this is the short form of the third law of thermodynamics. So in this particular lesson, or in this particular PPT, we saw 3 laws of thermodynamics in short. Definitely with the time, these 3 laws of thermodynamics will be studied in more detail, but for today we will stop here, and further information we will discuss in the next lecture. Thank you.